Evening, everyone. Thank you for attending tonight. We've got Steve Rainbow from Trend helping us on our next CPD on BMS and air quality in buildings. So I believe that we're now just gone past. There seems to be plenty of people turned up. We're gonna have a Q&A session at the end where we can unmute your microphone so we can actually make it a little bit more interactive. If you've got any questions, you can also add them in the chat box. I hope you enjoy it, and I'll pass over to Steve now.
Okay, fingers crossed the technology works yet again. Bear with me. I should hopefully be able to share my screen. If you could let me know when you can see the future buildings, healthy buildings. Can we all see that?
Yeah, that's good, Steve.
Right, okay, brilliant. All right, I say good evening, everyone. Thanks for coming on yet another webinar in what's been a really strange 18 months. My name's Steve Rainbow. I've worked in the industry for nearly 40 years now. Worked for Trend Controls, and really this CPD came around right at the onset of COVID. Obviously 1 in every 3 buildings in the UK has got one of our systems in. There were certain things happening. We were getting lots of calls. What have we got to do? What's the guidance? What can we do to make things right? So I was actually on holiday, came back and said, Steve, do you want to pick this one up? Which, to be honest, was quite a minefield, but I've really found it an interesting subject, and I can't believe we've not done more on it. So there'll be a Q&A at the end. I think, I've found in presenting this a lot of times over the last year that it does actually raise more questions. I'm hoping it fits in line with a lot of the conversations that you've had. I've been quite excited to do this one to Sibsy to get your take. What you've been asked and what the market and FM companies and people have been asking you. So without further ado, it should take probably 35-40 minutes to go through this formal presentation, and then I say we'll open it up for Q&A afterwards. So the agenda: what is a healthy building, what needs to change and why. We'll talk about the enhanced indoor air quality, which I'm sure you're all aware of, and like I say, we'll just have a couple of closing notes. Where is it going? What do we see in the future, and followed by the Q&A session. So what is a healthy building? So everybody's slowly but surely returning to work. We've had peaks and troughs. We've had instances where people have said we need to get people back into buildings, and then we've had a spike and they've not gone back in again. So it took me a long time to even go back on public transport, because you don't know what you're going back into. So you imagine in the middle of London, we look after a lot of large commercial buildings that make their money from renting office space. Okay, there's lots of schools and universities that again need to be occupied. So what we're trying to do was make sure that the environments that people were working in were as clean and as healthy as possible, and complied with what we were being given as industry guidance throughout the whole of this pandemic. I've a certain customer I look after in London. They could not close their offices for a start off. They had to operate 24/7, 365 in 110 buildings. So obviously there were implications to them. But what could they do to make things better and to make the buildings comply? There's still a fear of people going back, or certainly there was. I think we're slowly but surely getting back into this return to work and return to places. I'm actually going to the O2 Arena at the weekend, and on the tickets it states that they've actually implemented some air quality measures to make sure that the environment that we're going to for a concert are as clean as possible. So this bit of reassurance and making sure people are happier and want to go back to these places has played key on what we were doing. So basically, is the environment clean, safe and ready for business? That was the key. our employees, students, visitors and customers comfortable with going back. You know, like I said, it was difficult to get back into public transport, been just as difficult with buildings. And how quickly can we implement the change? Well, we're into it now. We know what's going on. We've done some major projects now where we've implemented some of the things that I'm going to be talking about a little later. So this is all up and running. Really what we're looking for now is to move into the future and park the COVID. You know, where does this go within buildings, you know, within the well space moving forward? I'm sure you're all aware that Honeywell own Trend, and Honeywell side, this was split into two elements really. They looked at the safety and security side, access control, people counting, temperature screening and things like that. That fell into the same category really as the healthy buildings, but I'll not dwell on that one. But if you need to know more, we can certainly get people to talk to you about that. This was no different than, you know, Aldi's limiting the number of people coming in, shutting barrier doors off, things like that. Obviously in our world, the HVAC world, in the controls industry, it was about this improved air quality and what can we do that was different from what we'd done before, and why were we actually doing it in the first place. So we looked at the market, and the first place that we looked at was hospitals. Hospitals seemed to be key, and I'm not really sure why, because everywhere where we were having gatherings of people, we need to implement the changes, and we needed to implement certainly initially just strategy changes in the way that the buildings operated, the way that the plant operated. You know, the way that people occupied the building, numbers were reduced. So there was lots of different things to do, and it applies to all of the sectors. Anywhere really where we've got a control system or we've got gatherings of people, we need to be implementing some form of reassurance, making sure that the buildings are as clean and as healthy as possible. I'll say now, and I'll probably say it again later on, is I'm not an air composition quality expert. You know, I'll leave that, and I'm not a viral expert. I'm a controls engineer. So we'll leave the high tech bit to other people, but hopefully you'll see where all this comes from. So that's a rather confusing picture. That creates the whole, that shows the whole end-to-end coverage. The red areas relate to the Honeywell access and security piece. It's more about these orange pieces that we can deal with. Okay. We'll start with negative pressure, probably not so much in commercial buildings, certainly within laboratories. Yeah, we need to have some pressure regimes to make sure we don't get any leakages of contaminated air within these laboratories or clean rooms. That's something that we can do relatively simply. What we've never really looked at before in any great detail was this, what we call it, enhanced air quality. And we've created now some sensors that sense temperature, humidity, CO2, PM2.5, TVOC within areas, yeah, that we can now start to look at this information. There was never really much science behind what we did, but if more data we can now put into the trend system, yeah, the more we can see what's actually happening. So even if we introduce local air purification devices, even if we opened a window, we would be able to monitor what was happening within that space. Okay. If we then introduce UV cleaning systems, local or within the duct or wherever, again, we can't actually measure viruses, but we know what these units are doing. We can link this data into the trend. And in certain instances, what we can then do is we can send that information and display it on a dashboard at the reception, certainly on the FM, the facilities manager's desk or PC. He wants to know what's happening. And I'm going to talk a lot about the science behind what we do, how we're doing it, why we're doing it. The why we're doing it, if you look at this, goes back to, this was the 3rd of April 2020. So this was the first guidance that we had, and I know that CIBSE advised REVAR. So they were saying that we need to introduce as much outside air into the space. We need to start running plant for longer. We need to, you know, not be turning ventilation off, toilet ventilation off, and we really need to be bringing as much of this outside air into the building as possible. This was when I first started getting my phone calls. Okay, so Steve, what do we do? Well, you've got to do, this is what you're being told to do. You need to run the plant flat out. Obviously, energy managers at this point in time are falling on the floor because all of a sudden the plant's running. But you know, that was what they were being told to do. ASHRAE. So this is obviously the American take on things. They said exactly the same, and this has changed throughout the last 18 months. But basically, again, outdoor air ventilation. Disable your recirculation systems, introduce greater filtration, MERV 13 or above. Now, keep the systems running longer. Introduce portable air cleaning devices and UV sterilisation devices. Maintain temperature and humidity. I'll talk about a little bit more in detail. And bypass energy recovery ventilation. At first, they said thermal wheels were the worst thing possible because every 180 degrees, anything contamination that came back through the extract ventilation was blown back into the building. There seemed to be, you know, guidance now to say that that needs to run as fast as possible, but you're losing any real heat reclaim benefit from that. So there's certain areas in this that are pretty sketchy, but the main thing is more fresh air, run the plant longer, greater filtration. CIBSE yourselves, and this one really has been key, and certainly that one word has been key when I presented this this CPD, because the reasonably piece is what we need to know. Certainly in the Northern Hemisphere, we know plant is not designed to run at 100% fresh air when it's really hot outside or it's really cold. Fortunately, we've not had, during this pandemic, extremes of temperature. We've probably had a few days of high temperature in the summer where chilled plant couldn't cope. We've had the same in the winter, but it's not been anything too drastic. But it's this piece really, just remember this, because this is the bit I want some feedback on a little later. We talk about risk assessments. As Trend, as a controls business, we have been carrying out risk assessments based on the controls and based on the guidance and based on the strategy that we needed to change to make the plant run longer. And it was CIBSE that has claimed or said about the droplets falling to the floor and the very, very small particles, these aerosols remaining in the air. Hence, we were obviously exhausting as much air as possible, bringing as much air back in, fresh air or outside air, back into the space. Then we get ASHRAE. So Honeywell as a company at one time, we were said, oh, you're just chasing ambulances. You know, this was a global, it still is a global concern. It's massive. And India said exactly the same. Yeah, as ASHRAE. We know the size of COVID. We want more fresh air. I emphasize fresh air, outside air. MERV 13 or above filtration, UV, G lights to disinfect the coils, and a combination of those. We'll be doing our damnedest to get rid of as much contamination within the space as possible. So this was it's a global concern. So how can we improve it? Proper air exchange is the first one. We need to be bringing more air in, getting rid of more. The right temperatures and the right humidity. We know 21 degrees C and 50% RH are good areas to be. But again, this is really good in the BEMS world, which I'll talk about a little later. Air cleaners, this is greater filtration, UV sterilisation, which I'm sure you've heard about, and the pressure control, which we've mentioned within specialist areas, clean rooms, labs, fume cupboards, etc. So we want to make these buildings more desirable places to work, learn and conduct business. You know, that is the future. We believe that the whole well-being moving forward will be looking at IAC in a lot more detail. So we're reassuring the spaces are safe for staff, occupants and visitors. Probably a bit buzzy these, make it safer, know it's safer and keep it safer. You know, we're parking the pandemic, we're parking COVID. What do we do? Where are we going to move in the future? You know, what are we doing as a controls business to move things forward? So enhanced air quality. Within Trend, we've had 2 air quality sensors for a long time. An ADQ, a duct sensor, and an ADS, which was a space sensor, but we didn't AQS, but we didn't really have that much science around what we were doing with it. But it's proven that we can, by measuring and monitoring what's in the air itself, we can make things better. So what can we film? What can we measure? What have we always done? Temperature has always been in a BMS system. We haven't got a BMS system if we haven't got temperature. Humidity, certainly within libraries, within museums. We used to have a lot more humidity control in office buildings at one time. I just seem to remember bottles of, furred up bottles lying around plant rooms, but there is still humidity. We can sense humidity very, very simply, and CO2. So this is key. This one is key to air quality anyway, and it has been for probably 15, 20 years. I would say, I first came around this when I ran one of the partner businesses, and we were looking at schools, and CO2, measuring CO2 in classrooms became the norm. So what we tended to do then was measure the CO2 with a sensor connected to a Trend controller. We would literally put a light on. It was a neon that was built onto the grid switch next to the light switch for the room. And when the light came on, the teacher would then walk over and open the windows. Very, very crude way of using a sensor and the BEM system to introduce more fresh air. And obviously it's moved on since then, because we can now influence the plant to do this. We can ramp fan speeds up, we can open dampers, we can open windows, so lots. So those 3 elements are something that we've worked with for a long, long time, everyday things. It was this piece that we'd not really understood, these what we call VOCs and particles, the particles in the air, that we'd really not got any, science behind what we were measuring or what we were doing, and these seem to have come key over the last 18 months. The virus side of it, we know we can't measure the viruses, but we do know if we introduce disinfectant solutions, we can reduce these viruses by X amount depending on the units used. But it's more a case of measuring these elements that was key to us. So if we looked at the 2-meter rule and the coughing and the sneezing, even just the talking and these infectious aerosols that float around in the air, the theory I believe is that these are going to be hitching a ride on some of these really small particles that are in the air. We know that a lot of the moisture surrounding the COVID virus evaporated, but these things were still moving around the building. Okay, so put that in perspective. If that's a human hair, PM10 would be the normal panel filter. Okay, and the pink dots on here, PM2.5, which is extremely small particles. Again, I look at this and think, you switch an overhead projector or a projector on, and you see this, white beam of light, and in that light stream, there's so many bits and pieces, and you've no idea what they are. And a lot of those will be PM2.5. So to put that in perspective, that's pollen, and that's PM10. That's PM2.5. So if that's COVID and this is other bacteria, we can understand really how that could possibly hitch a ride round on that airborne particle at PM2.5. So if we introduce filtration to that level there, then introduce the sterilisation, we are doing a damnedest. Again, like I said earlier, I'll emphasise I'm not an air composition expert, but obviously we know from science if we can get rid of as much of that as possible, we've got to be removing this. We have to be doing. Okay. So how did we go about this? Well, these were our typical temperature, humidity, CO2 sensors. So these have been installed within plant for a long, long time. Whether they go in the air handling plant or whether they go in the space, didn't really matter. And what we've now done is introduced PM2.5 and TVOC sensors to complement these normal analog devices. But what we have got now are these Modbus devices. And I know this is a CPD, so all of the other manufacturers are all following suit, but these all-in-one Modbus sensors are extremely clever. They are controllers within themselves. That's the same unit, but it just shows that it has a traffic light indication on it. Okay, that we can set, we can determine when this is green, amber and red. Okay, that's the duct version of the sensor, and there's probably 50 or 60 Modbus bits of information available in these devices, and they are doing temperature, humidity, CO2, PM2.5 and TVOC. So all of a sudden we now know what's happening in that space. So if that was a space that didn't have mechanical ventilation, but we introduced or opened a window, we'd notice a change and we can monitor that change. If we then start looking at the vent plant, this is where it really got interesting, because again, I have another client in London that couldn't adhere to the guidance because all of their units were fixed 80% recirc. There was a mixing box, but it had no dampers in it. So the only way they could get round, or thought they could get round, was to put filters and UV sterilisation in the return air and the supply air. But then they would measure the outdoor air coming in, supply air and return air to see what effect certainly the filtration it had. And they were finding the air coming back after it had been treated twice was sometimes cleaner than the air coming in. 8:30 on a Monday morning, this outdoor air was probably more polluted than the air that's been cleaned and sterilised and put back into the building. So that was one food for thought, really, that I'd like to raise with you. You know, with that, to me, if we've got parameters that we know we're working to, we should start to be able to reintroduce recirculation, which is going to obviously have a knock-on effect and energy saving, so long as it meets with the guidance numbers. Filtration wise, this is what we looked at. That would be your normal primary filter. This is 10 microns. We know HEPA filters are extremely expensive to retrofit. They are going to create massive pressure drop anyway. You know, it's not practical, but you know, operating theatres and very clean rooms will have that filtration. So the solution that Honeywell came up with was this electronic air cleaning device, this air cleaning filter. Okay, that only has a 60 Pascal pressure drop across it, so it's having no detrimental effect, but that is removing PM2.5 particles. So we're now to MERV 14 via this electronic air cleaning device. And then within the air handling unit, if we introduce UV lights, UV sterilisation to sterilise the coils and the unit from anything coming off that, we are doing our best to reduce, you know, any contaminants within the air. Electronic field devices, electronic air filtration, very simply charges the air as it comes in. There was concern over ozone that's created with this method. Again, I'm sure we'll get some questions at the end. Yeah, a lot of this ozone is contained. It's a very small amount. We charge the particles coming in, and then there's carbon collector rods within the unit that attract those positively charged particles and gets rid of them. And UV sterilisation, again, there's lots of science. You can't really measure what it's doing, but it has been used for a long, long time. And I know there's a lot of research gone into UV sterilisation. I'm not an expert on it by any means, but by introducing that, we are, you know, trying to do whatever we can to get rid of any bacteria that could be present. These can be retrofitted. They're connected to the BMS, which is pretty good, so we can have them self-cleaning. We know exactly what they're doing. They retrofit into standard air handling units. And then the UV sterilisation, the lamps. The only thing we can do on there is look at hours run. The science behind it is the fact it's done on volume, so that will be sized based on how many meters cubed we'll be going through that. You know, somebody within Honeywell who does the science calculations will say you need a 2-tube, 3-tube, whatever tube unit for that amount of airflow. So, enhanced air quality summary then. So this was a typical library, probably. We've got humidity, temperature, CO2 sensing within the space, occupancy sensing, so that could either be linked into the lighting control system, it could be linked into the time schedule within the BMS. So long as we know that the space is occupied and we're looking at these elements, that's the norm. That's what we would normally look at within an automatically controlled space. This is where we're going with the enhanced space. So that could be a lecture theatre, a boardroom. I'll give you an analogy in a minute, but basically, if we're measuring the elements within there and we know what they are, even by opening a window, opening a door, adding local device air purification or UV lights, obviously that wouldn't be on if the people are in there, we can monitor what's happening within that space. So I went to the dentist 6 months ago and they have a Mitsubishi unit standing in there. And this was reading TVOC PM 2.5. The dentist obviously hadn't got a clue what it was doing. So I said, what do you do with that unit? And this is after I'd checked my teeth out. And basically said, what we do, we leave that running for 15 minutes after each patient. And then we let the next patient come in. So I said, why do you only run it for 15 minutes? Or why do you run it for 50 minutes? Said, well, that's what the installer told us to do. So I said, well, what does it mean? Is that long enough? I said, don't know. So I said, well, surely if you knew what it was doing for that 15 minutes and you measured, it's obviously measured it internally. If you knew what it was doing, the chance are you may only need to run it for 10 minutes to achieve the levels that are required, in which case you could see more patients, or it may take 20 minutes, in which case you're putting patients at risk by not running it for 20 minutes. So all of a sudden the subject went away from my teeth and onto to enhanced air quality. That's the theory behind it. So it doesn't really matter what is, what's filling that space with air, whether it be, natural vent, mechanical, plant. It's all about this measuring that we've never done before. The more we can measure and the more we implement particle control, or we start introducing different methods, we can start looking at good, better and best systems. Obviously the best one is going to have everything on it. As far as I'm concerned, if we just measure the elements, that will be the best way to go, and I'll show you where I'm going with that one. We talked about temperature and humidity. There's quite a bit of research gone into it's airborne infections and what they do, and respiratory diseases and things relating to humidity and temperature. So we know within a BEM system, temperature is the key controlled element. So we've always controlled temperature to say 21 degrees C. We will set in there some parameters to say if it goes below 18 or it goes above 23, we can flag an alarm. So that gives us some parameters to work to. What that also does then within the BEMS world with humidity is again gives us this detail. So we can say at 50% R rates, that's a really good place to be. That would probably be where we'd have the green traffic light. If we start to drift above 60 or below 40, we could start to have the amber lights. And again, if we went below or above 65 or 35, we could go red. But what that's giving us then is the parameters to work to within the BEMS world, which again, we've always done. We've always had high and low limits built into things. Reset, somebody that ASHRAE have been working with, and somebody that, or body that we've been looking at, that have now given us data that relates to PM 2.5 and TVOC. So all of a sudden, we can look at temperature, humidity, CO2, TVOC, PM 2.5. So that's what the sensor measures anyway. And all of a sudden, we're now making sense of the elements that are in the air. So if they go away from what we're considering to be industry guidance, again, if SIBS have got any other data, then fantastic. The one that gets me or concerns me on this one is this one, which is carbon monoxide. So I showed you the air handling unit and the outside air. And for the last year, we've been telling everyone to bring as much outside air into that building as possible. I'm sure that in Tokyo, they've been wearing masks for the past 25 years outside because the air was so polluted. Yet guidance has told them to bring as much of that air into the building. So, you know, if that's only 9 parts per million carbon monoxide, wow, that's a low number in my mind. So I think these elements moving forward are going to be key in the design of control systems, you know, and plant control. So what can we do with that? What do we do with this data, this, you know, all this information that we're getting off these sensors? Their data's another buzzword at the moment, data analytics. You know, it's only as good as what we actually do with it. We have a supervisor platform. It used to be called a 963, it's now called IQ Vision. And that supervisor platform is where we would place all the data. And we again have worked with ASHRAE to come up with statistics. I'm sorry, this slightly blurred this slide. But this is where, again, we've sought lots of help and advice because, you know, we're looking at here, probably imagine that these were floors of a building, zones 1, 2, and 3. Yeah, what we're saying here is the average score for the building is 73%. Now, if you showed that information at the reception, certainly within a university, the students will say, well, where's the 27% where it's poor? Yeah, they're going to look at that negatively. This would be more of a facilities manager's tool. What it also does, it looks at these pollutants, and this is what we've discussed with ASHRAE, and looked at the reset numbers. So what is excellent? What is good? Yeah, what would be the ideal level for pollutants to give it a good score, to give it the green traffic light? Yeah, we know we can do it with CO2 because we've had that number. We know how many parts per million, and we know what humidity and temperature are. Yeah, and if we take an average of all of those, yeah, we can now give each space this healthy score. Probably even now, still work in progress. And, you know, some of our partners are coming up with different ways of displaying this information, because even though this is telling me it's average in this area and poor in there, it's only poor because the temperature and humidity are out. Might be throwing it down with rain outside and somebody's opened the window. It's actually telling us that CO2 and pollutant levels are good. In here, it's only telling us our pollutant levels are good. So they're obviously down on what the guidance should be. So like I say, as you can understand, yeah, there's still questions to be answered, but this now is working on real data. It's not just something that we've invented or made up. We talked about the dashboard. We have had requests to display very, very simply. I don't know if you're aware of an Energy Eye screen we used to have that displayed the energy usage within a building at any specific time. People are saying we'd like to see what's happening now regarding air quality within our space. What is it like? What's the building like? And even if we just take, you know, a corner of the television, a lot of, certainly with commercial buildings, have TVs within the reception now with the news running on them. Yeah, we can take a corner of that and put a little graph on just so that when this guy walks in, he's walking into a space that he knows is as clean as possible, you know, within the guidance that we've been told as a controls company. So this is where we're up to. Pressurization, we've done for a long time. Ventilation, temperature, humidity, CO2, standard BEMS things really. A lot of this, obviously, yeah, the changes were strategy changes, the running of plant for longer, bypassing heat exchangers and things like that. You know, the things that we've done. It's this new area to us, this air composition, that has been quite an interesting subject. You know, I've been asked, people have said to me, you know, HSE, if HSE were to look at this, would they be saying, well, you've implemented the changes, what effect has it had? Well, if we can't measure anything, We don't know what the air composition is. We can't prove what these changes have done. They might not have done anything. They might have made it worse if the outside air is polluted. But now we can measure it. It is making life a lot easier. And obviously, we've talked about the filtration, UV sterilisation. That would probably fall more into the mechanical contractor's remit than the controls, but we can certainly control and monitor and measure what those systems are doing. And as I've said a couple of times, you know, we're looking now to move away from COVID. It was it's been a dreadful time. There's been lots and lots of changes. I don't think anywhere will operate the same again. I know certainly within Trend, our offices are working a 3-2 basis, so people are going 3 days 1 week to the next. You know, so space isn't being as occupied as it was. But obviously in the real estate world, where these big companies are renting space, that's causing them a major problem. So they're looking more into making sure that their spaces are better than the competitor. And this piece comes into any of this human-centric well-being, well standards for the future. Everyone is looking now and mentioning this indoor air quality. So we're here at the journey at the moment with the healthy buildings. It's this human-centric piece that I believe moving forward, we will be looking in a lot more detail into this indoor air quality. Again, this is another one. And again, it's looking at air quality. I think the only take I've had from this is why have we never really done it before? If you look at IAC, people have done it, but not obviously to the degree that they have. We concentrate a lot on outside air and traffic movement and flight paths and different things. We don't seem to have done much work, certainly within fully air-conditioned buildings on this indoor air quality. People have said, sick building syndrome, does it link into this? I don't know. I said again, I'm not an air quality expert, but theory, yeah, it could do, couldn't it? Yeah, I don't see why it doesn't. Now we can measure it. It's got to make a change. So that's the formal presentation over. It's about a minute and a half quicker than I thought I was going to do it in. I've probably told you a lot of things you already know. I'm intrigued to see what questions you throw back at me. Hopefully we've gone down the right path. We seem to have done. There's a lot of companies looking to measure and monitor what's actually happening within their spaces. So without further ado, what I'll do is I'll stop presenting and I'll pass back to Ella and see if we can open the screen up to some questions. So thanks for listening, and we'll catch you in a second.
Jared, Miru, I don't know if you want to moderate the Q&A, but everybody's microphones aren't restricted anymore. Thank you.
Yes, does anybody have any questions or would like a little bit more information? I certainly found it very interesting, Steve. It was interesting finding out about the sensors, because you can know you have a problem. It's always difficult to know how to fix it until you can measure it.
Yeah, I think the worst thing is because it's been such obviously a sensitive subject. No one's going to claim we're getting rid of COVID, and no one's going to claim we're going to get rid of bacteria. The biggest issues that have come out for me are the energy managers saying this is terrible because we've got, certainly now we've got COP26 going on, and we're being told to run the plant 100%, flat out. Surely that's not energy efficient. That's got to be. But it seems to have been the health over wealth issue for the last year, that let's keep people healthy rather than worrying about the electricity bills. That's got to be key moving forward. And the other bit was the design side of it, that buildings plant is not designed to run at 100% fresh air, certainly in the UK. So what do we do moving forward? Is a specification now going to come out and say we'll have summer, winter pandemic modes built into the BEMS? But that will mean, do we put an extra chiller on the roof? Do we put an extra heat pump in the plant room?
Yeah.
So lots and lots of questions. The big bit for us, obviously, is we can now measure and make sense of what people are doing. And if it fits in within that guidance, yes, we can start introducing recirculation, because if it's still within reset's guidance, then it's got to be it's got to be right. And that relates again to the SIBSI reasonably word, as much as reasonably possible.
Yeah, we need to run the plant efficiently. It's always been difficult to, what is good air quality? As you say, there was a lot of research done when people were allowed to smoke in offices and how to limit that. And then when the banned smoking in buildings, it kind of died off a bit, the research.
Yeah.
This has had to force people to do it, and it's not just that. It's you're forever squeezed for services in a building, but the efficiency standards are pushing for greater air volumes, lower pressures. So I need more space for my plant and the distribution system, and it's getting that balance. But it's good to know that you've got a control system now that can inform people.
Yeah, and it started off with a reassurance piece, really. If we can say to people and put a green traffic light to say this is the best that you can get. Like I say, the O2 have told me that on the tickets. They have put in greater filtration. They've put in UV sterilizer within the ductwork systems. They're bringing more fresh air in. Hopefully, Mr. Ticket purchasing customer, that's going to make you feel happier about coming to the O2. That is the theory with everywhere else. There's a big client whose buildings weren't occupied until 2 weeks ago that have put this in purely for the fact to be able to say to the people coming back, this is what we've done. While you've been working from home, this is what we've implemented to make sure that you're coming back into something good. I just wondered if anyone else has come across specific projects or specific sites where they've been asked this question.
Well, we are being asked more now that the country's being open. So I'm sure you'll be getting a phone call from this company I work for. So we've been asked to give advice, and we have all the way through. But like you say, it's been limited because normally it's a few years after scientists have done the research in the lab before it comes out into the real world for use.
I mean, the Americans
very quick.
Yeah, the Americans have jumped straight on it, and they've said that's it. We're not opening a shopping mall. We're not opening a school or university until you've implemented some form of enhanced air quality control. Whereas over here, in the wonderful world of contracting that we live and breathe in, until it's stamped in the specification or it's stamped in Part L to say this is what you need to do, it will get bypassed. It's down to the client's individual choice. Do we need to have enhanced air quality? Like I say, 2 or 3 years time, I think they will.
Yeah, and at the end of the day, there's still the Health and Safety at Work Act, so they can be prosecuted if they're not taking reasonable. So and I think sometimes that's why the UK takes that view.
Accountability. It's accountability, isn't it?
Yeah, they prefer the industry to sort the problems out rather than legislating for it. So they've got an overarching piece of legislation, but and then provide the guidance and rely on people like SIBSI and the partners that SIBSI work with to come up with the guidance.
Yeah, it's going to be
that's all it is.
It's going to be difficult to bring a prosecution under Health and Safety at Work for contracting COVID because you don't know if it's linked to somebody who's 6 floors away or your next door neighbour.
Yes, I know what you're saying. But if somebody said he made everyone to go back to work and sat within 5 metre squared, 5 metre cubed office space, when there's a known risk and didn't take any precautions, they could open themselves up for prosecution or some legislation or litigation.
But those people have just travelled to work on the train and the bus anyway.
Yes.
Yeah.
So the dreadful thing with the whole thing with COVID, like I say, I'm not an expert on it, is the fact you can carry it without any symptoms for 2 weeks, and that's been the dreadful thing with it because nobody knows where they're getting it from. But hopefully we won't see it again for a good long time. But this one isn't going to go away, I know, but
I think some of the early estimates were that something like 80% of people with infections of COVID had no symptoms. I don't know what the current view on that is, but I believe more people are carriers without knowing it because they've been vaccinated.
Oh, it's scary, isn't it?
Yeah.
Yeah. I mean, I just look at the numbers. still look at the numbers on a daily basis. Unfortunately, you know, they're not going up. But
all the hospitalisations.
Vaccine program has been a saving grace by reducing the levels not of infections necessarily, but of hospitalisations.
Yeah,
and it's going to be part of what we need to learn to live with. It's just another nasty like flu and all the other things that have floated around for decades.
Yeah, I think it's been a big one though, because it is actually it's altered how we work and how we approach work as well, hasn't it? How we approach things now.
But you imagine if every year the government published the deaths from flu over the last few decades, not quite on the same magnitude, but certainly significant, and people just accept it.
Yeah. I've taken that view a long time. The natural deaths is 11,000 a month or something. So but there we go, politics.
Yeah.
So, but there you go. So hopefully, I say you found it. I'm sure you're all aware of this anyway. You know, straight away alarm bells are ringing with a lot of our clients. What do we do? How do we do it? And so far, we've implemented the strategy changes, the running the plant, and now we're starting to put, you know, sensors in and starting to run things back, trying to get a bit more energy conservation in there to meet that reset guidance. That's where we're going.
Yeah.
How are you implementing the addition of high efficiency filters? And the poor bugger's got to go and change them periodically. Because in theory, he's got to swap out a unit that's infested with potentially live virus.
Yeah, and that's another problem that's arisen, isn't it, with filter changes moving forward, is that's now become a hazardous chemical activity.
Yeah.
So people changing your old panel and bag filters on a 9-monthly whatever basis as part of the PPM are now having to go in and treat it as an asbestos type risk. So again, you know, that's another question to ask, you know, the FM companies, the mechanical people that are implementing the physical changes. You know,
what risk is it? Like asbestos, or as you say, a biohazard.
Yeah, which you have got to do, surely, if we're saying that the return air could be contaminated.
Yeah.
So that's what I say. It does raise, the more you think about this, it does raise some questions. You know, fresh air. It's not fresh air. It's outside air, and outside air can be pretty grim stuff. You know, one of the buildings that I've looked at is on Heathrow's flight path, and they're convinced that sometimes they're dumping kerosene or whatever it is. Yeah, they can smell it in the building. They can virtually taste it as the planes come over.
Yeah.
So they were really keen to measure what was actually happening, not just your normal elements, but they were really keen to see what was actually happening in the air. So
the big driver at the moment has been COVID, and you can't actually measure COVID, as you said. You can only measure by influence by number of particulates.
Yeah. But I didn't realise there's actually standards for TVOC. There's standards for carpet tiles, aren't there? Because they give off a lot of real bad, nasty stuff.
When we put in a new building, very often one of the tests we have to do is to measure VOCs being given off by carpets, soft furnishings, MDF, and various other elements in the building.
Yeah, scary.
There's obviously a finite amount contained in those objects, and that will leach out over time.
Yeah. So now we can constantly measure that as well.
Yes, but what you're measuring is what's being drawn in from the outside air rather than what's inherent in the building substance.
Yeah.
Well, you can actually measure what's in the return air, can't you? Put in the return air, you can measure in the room as well, can't you?
Yeah. What you're actually measuring though is initially the decay rate for what's coming out of the furniture and fittings until you get down to a base level of what's being entrained in the atmosphere that you're pulling in.
Yeah.
I'd be interested to know how your boffins came up with sizing of the UV filtration. Taking out particulates is a good first step because the effect that you get is shadowing.
Yeah.
So, you know, if a virus is on a particle and the particle happens to be between it and a UV source, then it's not effective. So, and the other critical factor is contact time. How long is that virus exposed to UV for?
Yeah. What I can do is I can share some of the data sheets if you want. I can certainly do that. I'll get them over.
Feel free, Steve. If you want to send them to me and Maru, we can share them.
No. I'll share the presentation.
Or if they're on the link, that'd be really good if you can. If you can send it to me, Maru, and Ella, we'll get it uploaded.
Yeah, it'd be good to get some feedback, because obviously what it does, it's the sensor's obviously got all the Modbus tables. So what it will do is tell you what, we can measure TVOC at A level for a set amount of time. Yeah. You don't have to configure that in the software anymore. It's built into the sensing device. It's very clever stuff. So any feedback, I'll share. I'll share all the data sheets on the electronic air cleaners, the UV sterilisation systems, everything.
Or send us a link to download.
Yeah, no problem.
Are you putting those combined sensors on the fresh air intake to measure what's coming in?
Yes. It depends what people want to do. Obviously, the fresh air, the one that we haven't got, the element that to me is still key, is the monoxide, carbon monoxide. That's the dangerous one, as far as I'm concerned. Yes, we can, obviously, if we look at fresh air and then we look after an air handling unit in the supply air, or even, I would implement the filtration and sterilisation. In both, sterilisation is only sterilising the unit. It's only doing the coils within the unit. It's removing what's in there. But I say that one, the example where I said they've got 80% fixed research. They couldn't, physically do anything. They'd put filtration and UV sterilisation in the supply and extract, and they were reading the readings that they were getting on TVOC and PM 2.5 was amazing. So the air was that clean.
You've got a bit of a dichotomy going on. You've got the issue of keeping COVID out of buildings, which would drive you to full fresh air all the time. But things like particulates and CO2 or carbon monoxide, or even the kerosene that you mentioned in the Heathrow flight path, drives you to recirculate.
Correct.
And you've got the two things opposing each other.
Yep. So you can see now I've spent the last 18 months, quite interesting subject.
Yes.
Above and beyond my day job, I've found it quite, and every time you turn another corner, you'll find something else, or you'll have a client who's got another issue with it. It's like the prove it piece. You've implemented all this change. You've spent the last, 2 or 3 months changing all your strategy within your air handling units. What difference has it made? Well, I don't know. Well, you need to know. How can we do it? So, well, let's put the sensors in then, so we know what we've done. Has it had an effect? So that's just
difficult to know if it had an effect if you weren't measuring it before. So you've got
in the first place.
Results. Yes,
correct. But new builds, I think, moving forward, I'd like to see enhance their quality sensing being written into specifications. That's how I write specifications for clients, and that's what I would like to see moving forward. Is certainly consideration towards, because I say, unless somebody says you have to have it in the UK within the contracting world, if you just get value engineered out, don't need that.
Yes, indeed.
So there we go. So I see Nick, it's got his hand up, or
yes. Hi, Steve. I'm just wondering if you could just say or explain a little bit further. You there was a comment you said about you don't want to introduce more low pressure into the building, and I was wondering if you could explain further why.
Low pressure or pressure drop?
Pressure drop. Yeah.
Yeah. Well, the system will be designed on X amount of air changes, won't it? So if we suddenly start to put in a PM5 filter where a PM10 filter was in, you're going to introduce a pressure drop. And if we introduce that pressure drop, we're not achieving the desired airflow rate. And if you look, I should have explained more about the risk assessment, because what we're saying there is, if we saying that we can do your controls piece, if you start making changes to the plant, then they need to be getting consulting engineers to look at the effect of introducing resistance into that air handling plant, because it's been designed to give X amount of air changes. And that's another subject that's been risen about air changes, because there's not as many people in the space. They said, do we need as much air then? Now, again, I don't know if that's something you've come across, but I would say no, you don't want to, we don't want to impact the design of the system in its first instance. So we can't just sort of willy-nilly start putting high resistance filters in there to filter the air if it's going to have a detrimental effect on airflow. Does that answer the question?
Yeah, that was great. Thanks very much.
I can say that's because all the guidance out there is still saying bring fresh air in, isn't it? So if you actually reduce the air, the general consensus in the scientific world is you're going to make the case worse, even if you put infiltration in.
Yeah. Worst thing to do when you're building with a BMS system is open the windows. Times we say don't open the windows because you just have an effect, but now everyone's saying open the windows, bring more fresh air in. So it's been an event for 18 months, as you can imagine. So we're just trying to bring as much theory into it as we possibly can, you know, and it seems to be working. It seems to be. But we've got another winter coming up now, so this is where 100% fresh air isn't very good at 2 in the morning when it's -5 outside.
Unless you've got a bigger heater battery to cope with it.
Correct. Yeah. But you'll find a lot of frost batteries will shut down at that anyway.
Yeah.
And obviously you've got more bigger heater batteries. We need more bigger heat source. Same with chillers. Chillers were locking out when it was hot. We had a couple of days where it was over 30 degrees and the chill plant couldn't cope. It's probably designed to run at maximum of 25. So it's a northern hemisphere problem. So it's not just the UK. That's again what we researched. Revive have done a lot of work on that. But it is, everybody seems to be saying health over wealth and run it. And if it's cold, then hard luck. I've had instances where they've had to put electric heating into the buildings to warm the feet of the people that are working at 2 in the morning. They can't do it. But then the vent plant will shut off as well because it's going off on frost. Yeah. So it'll switch off on the frost stack because the coil can't cope. So yeah.
My daughter-in-law's a teacher, and their school's regime is keep the windows open all the time. But of course, in the recent cold spells, and it's not got really cold yet, they're absolutely freezing in the classroom.
Correct. So you imagine what it was like in these buildings in London that couldn't be unoccupied, and they were running flat out, full fresh air, middle of winter and the middle of summer. And the buildings hadn't got the electrical capacity to put electric heating in either. Yeah. It really did create a problem that no one had ever predicted before.
Yeah. And then you run into another problem on health and safety at work in terms of minimum temperatures to occupy.
Correct. So your KPI on temperature 16 degrees C, people will leg it then anyway. So again, that'll revert back to Sibs's reasonably words, which means bring as much fresh air in as reasonably possible. So if it goes below 16 degrees C, it's not reasonable. So we have to introduce recirculation. So it's, like I say, told you it's quite an interesting, I found it quite an interesting subject.
Lots of competing elements.
There are indeed. So yeah, I hope you found it interesting. I'll share as much as I can, and by all means, if you come up with anything or you come up with a client who's asking strange and wonderful, weird and wonderful questions, I've probably heard them. And again, big thanks to Sibsy and Maru for letting me have this hour with you guys tonight. It's been really good.
It has been.
Thank you very much, Steve. I've got another meeting to go to, so apologies. I'm going to have to wrap this one up. But yeah, if anyone's that, on another point, we are actually having a UV filtration sterilisation seminar in the new year organised. So for manufacturers, so following along the same solutions that you've talked about today. So that's excellent. That's great. Thank you very much. It's really good. We'll, like I say, if Steve can send us the PowerPoint, we'll upload that. This talk will be on the presentation will be on our YouTube channel, so you can jump onto that and have a look at that if anybody knows. And you should be getting a CPD certificate in a few days, I believe.
Absolutely.
Thank you very much, everyone.
Thank you, Steve.
Okay, no problem. Thanks, everybody.
Yeah,
are we hanging up for our committee meeting now?
Yeah, I'll jump onto the other one.
Okay.
Cheers. Thanks, Steve.
I'll be